Okay, let me show you the second method by which you can see the electric force. This process is referred to as charging by induction. What I have here on the desk in front of me is what is called an electroscope. Okay, the electroscope, first of all, consists of two metal sticks, two metal conductors. One stick is right here, and then the second stick can rotate away from the first one like so. Conducting materials, such as metals, easily allow negatively charged electrons to flow within that metal. Okay, positively charged protons, however, do not flow within the metal, and the reason why is because positively charged protons are basically locked up in atomic nuclei. And then these two conductors, they're surrounded by this insulating shell. Insulators are materials that very simply do not easily allow electrons to flow within them. Okay, now I have my rabbit fur and my plastic rod and my glass rod from before. So let me go ahead and first of all rub up the plastic rod here, thereby giving it a positive charge. That is like so. And then watch what happens with the electroscope here when I bring this positively charged close to the electroscope. Like so. Notice that the two pieces of metal there, the two conducting materials, they then repel each other. Now the exact same thing here is going to happen when I then charge up the glass rod, thereby giving it a negative charge. That process then looks like this. So let me once again go ahead and charge this up by friction. That is like so. And then I'll bring the glass rod close to the electroscope and you once again see an electrostatic force of repulsion. Okay, here's what's occurring in this simple demonstration of this manifestation of the electric force. Once again, this process is called charging by induction. Okay, now generically we refer to the two pieces of metal within the electroscope, by the way, as leaves, and here's a very simple diagram that can illustrate that. I'm not going to actually draw the geometry of the electroscope itself. Instead, I'm going to draw the electroscope in the following way. Okay, a metal stick basically, and then these two pieces of metal that are hanging from this metal stick. Once again, these guys here are referred to as the leaves. Okay, and then let's say that right here is, first of all, my positively charged plastic rod. Like so. And this then attracts negatively charged electrons within the metal. Once again, because it is a conducting piece of metal, this then means that the electrons can easily flow within the metal. So basically, some of the electrons associated with the metal's atoms down here at the bottom of the electroscope, they basically get attracted right here towards the positive charge. So there's a slight flow of electrons, if you will, in this direction. So because the electrons become attracted to the positive charge, this then means that the top of the electroscope becomes negatively charged like so, and the bottom of the electroscope, which is now missing electrons, becomes positively charged. Like so. When you take a piece of metal in this case, or any object by the way, and you then split the charge within that piece of metal, this is referred to as polarization. That is, the piece of metal is now polarized. Okay, however, these two positively charged leaves now down at the bottom of the electroscope, they then repel each other. Like so. So that's what you saw then in the first of the two demonstrations when I took the positively charged plastic rod and brought it close to the electroscope. The exact same thing happens when I bring the negatively charged glass rod close to the electroscope, but the flow of the electrons very simply is in the opposite direction. So here's what happened in that case. Okay, so once again, I'll just simply draw the electroscope like so. And then here are the leaves. Okay, and then I bring the glass rod close like so. Okay, the glass rod has a negative charge associated with it. Okay, then in this case, the negative charge associated with the glass rod, that then repels electrons within the electroscope. In this case, the electrons flow downwards on my diagram like so. So because some of the electrons have left the top of the electroscope, this then means that overall the top of the electroscope becomes positively charged, like so. But now you end up with some extra electrons down here at the bottom of the electroscope, like so, thereby once again causing polarization within this piece of metal. Compare this diagram, however, to the one previously, and you'll notice that the splitting of the charge here is basically opposite of what it was before. Regardless, however, these two negatively charged leaves, they then once again repel each other. Like so. So that's why you saw basically the same thing in the two versions of this demonstration. With the positively charged plastic, the leaves repel. With the negatively charged glass, the leaves repel as well.
Yep.